So we have completed. So just we'll glance. So we have completed the introduction part, right? So after that, we had started with the different methods for expressing the concentration of solutions. So we have done mass percentage, mass by volume percentage, okay, parts per million. So we have deal with the different formulas, mole fraction, molarity, molality, normality, right? So based on this, we have solved some questions also. So that after that, we had discussed the Henry's law, Raoult's law. Okay, then ideal solutions, what are non-ideal solutions? So based on that also, we have solved some questions. So now, I think we have stopped here, right? This particular question. So we need to start from yes, this question. So here, so the question is, out of the below two compounds, the vapor pressure of B at a particular temperature is. So there are two compounds given. So first compound A, it is a para-nitrophenol, and the second compound is ortho-nitrophenol. Okay, so out of these two compounds, you need to tell which of the vapor pressure of B. Is it higher than A? Or is it lower than A? Then the vapor pressure of B is higher or lower than A, depending upon the size of the vessel, or same as A. So you need to tell whether the vapor pressure of B compound is higher or lower than A, depending upon the size of the vessel, and same as A. So when you compare this two, okay, when you compare these two compounds, so the first is what? First is the first compound is para-nitrophenol. Okay, it is a para-nitrophenol. This is ortho-nitrophenol. Right. So here, what you can see here, so that you can see that in ortho-nitrophenol, okay. So what type of bonding or what type of interaction is there between this OH group and NO2 group? It is a intramolecular hydrogen bonding. You know what is hydrogen bonding? Hydrogen bonding occurs between a highly electronegative atom and the hydrogen atom, right? So, so here you can see, so this OH, okay, and the nitro group N, double bond O and O minus, I can write it like this, and there will be within the molecule, there will be intra hydrogen bonding. So there are two types of hydrogen bonding. One is hydrogen bonding, intramolecular hydrogen bonding, and the second is intermolecular. What do you mean by intra? Intra means within the same molecule. Okay, within the same molecule. Within the same molecule. And inter means what? Different. Okay, between the different molecule. For example, inter-college competitions, right? Inter-college competition means what? The competitions between two different colleges. Intra means within the same college. So that is inter and intra meaning. Okay. Now in the B compound, you can see there is intramolecular hydrogen bonding, and A compound, there will be intermolecular hydrogen bonding. So in B, there is intramolecular hydrogen bonding, and in A, there is what? Intermolecular hydrogen bonding. So due to intramolecular hydrogen bonding, the vapor pressure of B is higher than that of A. So option A is the right answer. Okay, so vapor pressure of B in case, so it is higher. Why? Because of intramolecular hydrogen bonding. So the interaction between the two these atoms. Okay, so there is intra. So within the same molecule, there will be interaction. So because of this, the vapor pressure of B is higher than that of A. So option A is the right answer. Okay. So we'll go for the next one. So in a mixture of A and B, components show negative deviation when? Yes. Can you answer this? So in a mixture of A and B. So what is a mixture of A and B? Mixture means it consists of a solute and a solvent. So A and B are nothing but your solute and solvent. So if you have a solute and solvent, so the components show negative deviation. So when does it shows a negative deviation? When AA interaction is stronger than AA and BB interaction, or a second option, AB interaction is weaker than AA and BB interaction. C, delta V, that is delta V mixing, okay, is greater than 0, and delta S mixing is greater than 0. D option, delta V mix is equal to 0 and delta S mix is greater than 0. Yes. What will be the answer? Try answering it. So in a mixture of A and B, that is solute and solvent, the interaction will be stronger than AA and BB interaction. So option A is the right answer. So AB interaction, that is solute solvent interaction, is stronger than AA and BB interaction. So option A is the right answer. Okay. So we'll go for the next one. So these are all theoretical questions. Next, which of the following liquid pairs will show positive deviation from Raoult's law? So which of the following liquid pairs will show positive deviation from Raoult's law? A, water hydrochloric acid. Hydrochloric acid is HCl. Then water nitric acid, that is HNO3. Okay, acetone and chloroform. And D, benzene and methanol. So out of this four, the one pair which shows positive deviation is D, that is benzene and methanol. Okay, benzene and methanol, that is CH3OH. So benzene and methanol, they will follow the positive deviation from Raoult's law. Okay, so the liquid pair which shows positive deviation is D, that is benzene and methanol. Next, we'll go with the colligative properties. Okay. Now, what are colligative properties? So, there are 4 colligative properties mainly. So, the first is relative lowering of vapor pressure. Okay. What do you mean by relative lowering of vapor pressure? So, that we'll see. Then, second is elevation in boiling point. Third is depression in freezing point. And the fourth is osmotic pressure. Okay. Then, fourth is osmotic pressure. So we'll see one each. So we are directly going with the last equation. We are not going to solve it. Okay, so we are going to see directly the last equation. So the first one is relative lowering of vapor pressure. Okay, so when you're talking about relative lowering of vapor pressure, so the formula or the equations which is used is, so this is what, this is psi b, that is mole fraction of component B. Okay, so this is that is mole fraction of solute B. So mole fraction of solute B can be calculated by number of moles of solute, okay, upon total number of moles of A and B. Okay, that is solute and solvent. So it can also be given as P naught A minus PA upon P naught A. So this is the relative lowering of vapor pressure, the formula which is used. So NB is nothing but it is a number of moles of solute. Na is number of moles of solvent. So this equation can also be written as, so for NB, okay, by NB upon Na, for the dilute solution. So if you consider a dilute solution, so where NB, that is number of moles of solute, is very, 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 very less than Na, that is number of moles of solvent, then it is taken as infinity, that is, it is taken as unity. Okay, it is taken as unity. So it will be NB by Na. So this is the equation. So you know how to find the number of moles. So if you take NB by Na, so relative, that is number of moles can be calculated as a what? Number of moles is equals to given weight upon molecular weight. Okay, so given weight, how do you calculate given weight? So given weight will be expressed as, so now we are writing it for NB upon Na. So NB, so given weight of solute will be WB by, what is the molecular weight? Molecular weight will be MB. Okay, so this I am writing for NB first. So that is how you write number of moles. Number of moles can be calculated as given weight upon molecular weight. So this is a given weight of NB, that is solute, upon molecular weight of B, divided by, now we'll write it for Na. What is the Na? What is the given weight? It is WA by, what is the molecular weight is MA. Now I can write this again, rewrite it as this. How I can write this? WB divided by MA, MB into, so this can go to numerator and this can be MA by WA, right? So this is the formula to calculate the relative lowering of vapor pressure. Now what are the terms involved in this? So WB, okay, WB is what? WB is the weight of the or mass of the solute, and MB is what? MB is the molecular mass or molar mass of solute. MA is what? MA is the mass of solvent. What is WA? WA is the molar mass of solvent. It is the molar mass of solvent. So this is relative lowering of vapor pressure. So the formula you need to remember is this one and this. Okay, so for dilute solutions, that is for number of moles of B, if it is very, very, very less than, that is number of moles of solute, if it is very, very, very less than Na, then we are going to consider this particular formula. Okay, and so these are the, so these formula you need to remember for relative lowering of vapor pressure. So next, so next is elevation in boiling point. Okay, so how do you calculate elevation in boiling point? So elevation of boiling point can be given as delta TB is equals to KB into WB into 1000, okay, divided by MB into WA. So this is the formula of elevation in boiling point. So where KB, it is the molar elevation constant. It is called as what? Molar elevation constant. Okay, and it has the unit of Kelvin kg per mole. So it is having what unit? It is having the unit of Kelvin kg per mole. So this is elevation in boiling point. So delta TB is equals to KB into WB. So this, if you want to find the molar mass of the solute, so molar mass of the solute is equals to 1000 into WB into KB divided by delta TB into WA. So you we have just rearranged it. So either this or this. Okay, if you remember one. So so MB, if you want to find the molecular mass of the solute, you can just take it out and you can put the remaining things. Okay, so this is the formula which is used in elevation of boiling point. So next is depression in freezing point. Okay, so next is depression in freezing point. So how do you calculate depression in freezing point? So it is given as delta TF is equals to KF into WB into 1000 divided by MB into WA. Okay, where, okay, or MB, if you want to find the molar mass of solute, is equals to Kf into WB into 1000 divided by delta Tf into WA. So where Kf is the molar depletion constant, which is having the unit of Kelvin kg per mole. Okay, so this is the depression in freezing point. So these are the formulas which is used to calculate the depression in freezing point. Okay, so we are just seeing the final equation. Next is osmotic pressure, very important. So what is osmotic pressure? The osmotic pressure of a solution is the excess pressure that must be applied to a solution to prevent osmosis. Okay, so it is the excess pressure that must be applied to a solution to prevent osmosis is called as osmotic pressure. So osmotic pressure is given as pi. So pi is equals to CRT. So this is the formula to calculate your osmotic pressure. So osmotic pressure is denoted by pi, and pi is given as CRT, where C is the concentration. Okay, C is the concentration of solution. Then R is the gas constant. R is the gas constant, and T is the temperature of solution. T is the temperature of solution. So these are the terms which are involved. Okay. Now, what is concentration? So concentration. So what do you mean by concentration? So concentration is nothing but number of moles of solute divided by volume of solution. Okay, divided by volume of solution. So this is concentration. So the concentration is expressed as number of moles of solute divided by volume of solution. Okay, now how do I write this? So concentration is equals to number of moles is of solute. So it is NB divided by what is volume is V. So can I replace C by this into this particular formula? So what it becomes? So it becomes pi is equals to, okay, it becomes what? Pi is equals to, okay, it becomes pi is equals to CRT. So what I'm going to do, I'm going to replace C by this. So it will be pi is equals to C is what? MB by V into RT. Okay. So this is the osmotic pressure you can calculate. So you can calculate the concentration by finding out the number of moles of solute by concentration, volume of concentration. This can be rearranged by this. So V, if I shift here, so it becomes pi V is equals to WB. How do you calculate number of moles of solute? Number of moles of solute, again, given weight upon molecular weight. Okay, given weight upon molecular weight is nothing but your number of moles. So again, if I substitute your given weight upon molecular weight, it becomes what? WB by MB into RT. Right? So this is that formula. So you can use this. Now, if I want to find MB, okay, we want to find the mass of molecular mass of the solute. So I will take this here. MB is equals to, so WB RT. So this pi V will go and shift here. Okay. So these are the formula which can be used to find the different terms. Okay. So osmotic pressure is very important. So you need to know how do you calculate concentration and number of moles. Okay. So this is very important. So remember what is concentration, how do you calculate concentration, and how do you calculate number of moles. Okay. So this is osmotic pressure. So remember what is the formula used here. So now we'll solve some questions. So what weight of glycerol should be added to 600 grams of water in order to lower its freezing point by 10 degrees Celsius? So this is the question. Okay. So they have asked the weight of the glycerol. Okay, solute. Now here what is, so solute is glycerol and solvent is your water. So they have asked the weight of the solute. So weight of the solute is WB. Okay. Then weight of the solvent is given. So weight of the solvent is how much? 600 grams. Okay. 600 grams. Then what else is given here? So WA is given, WB we have to find out. Then they have given what? 10 degrees Celsius. 10 degrees Celsius is what? Delta TF. Okay, delta TF is what? 10 degrees Celsius. Then we know the molecular mass of glycerol is what? It is 92 grams per mole. Okay, so the molecular weight is 92 grams. Now we know how to find the freezing point. It is delta TF equals to Kf into M. Okay, Kf into M. Now, what is delta TF? Delta TF is given as 10 degree. What is Kf? Kf, we know it is given as 1.86. This value is constant, so it is 1.86 into, how do you calculate the molality? Molality is what? That is molality is given weight upon molecular weight. So weight of the solute is WB into 1000, okay, divided by molecular weight, okay, molecular weight of solute into weight of the solvent. Okay, so this is the formula. So now we will add what all we know. So 1.86 into what is WB? We don't know WB. We'll keep it as it is into 1000 divided by what is MB. MB is 92 glycerol. Okay, then what is WA? It is 600. Just see what answer you are getting. So I want to find what? WB. So I'll take this WB outside and this I will shift here. So what will happen? This will go to denominator. Okay, this will go to denominator. So what will happen? So this will come here. Okay, so 10 will go this side. So it becomes 10. This will come to numerator. So it becomes 92 into, this will go to numerator. It becomes 6. And 10 into 1 point, it becomes 18.6. Okay, so find out now. Just see. Solvency, what answer you are getting? Your answer should be, something around 296.7 grams. Okay, so it resembles to your option B. Option B. So it is 297 grams. Okay, so it is 297 grams. So option B is the right answer. So option B is the right answer. Okay. Understood? Understood this problem? Okay, so we'll go for the next question. The osmotic pressure of a solution can be increased by, okay, A, increasing the volume, B, increasing the number of solute molecules, C, decreasing the temperature, D, removing the semi-permeable membrane. So we'll see. So what is osmotic pressure? How do you write osmotic pressure? What is the formula of osmotic pressure? Is given as pi is equals to CRT. The first is what? First we'll see for temperature. Okay. Now you can see that osmotic pressure, okay, is directly proportional to temperature. Can you see? Osmotic pressure is directly proportional to concentration, gas constant, and temperature. So first we'll see with respect to temperature. So if osmotic pressure is directly proportional to temperature, so if osmotic pressure is increased, okay, if osmotic pressure is increased, what about temperature? So temperature also will be increased. If osmotic pressure is decreased, what about temperature? Temperature also will be decreased. So is it right that if osmotic pressure of the solution is increased, then temperature will decrease? No. So this option is wrong. Okay, so option is wrong. So osmotic pressure, if it is increasing, then temperature also should be increasing. But here they have given what? Decrease in the temperature. So this is ruled out. Now next we'll see. Okay. So next we'll see about concentration. Okay, we'll see about volume and concentration together. So how it is? Okay, concentration. We'll see about concentration. Just a second. So here pi is directly proportional to what? Concentration and temperature. Concentration is given as what? Number of moles of solute divided by volume of solution. Okay, divided by volume of solution. So this is concentration. Now if if I increase the volume, okay, now we'll see about volume. So what is concentration? Concentration is given as number of moles of solute divided by volume of solution. Now if I increase the volume, okay, what will happen to concentration? Concentration will decrease. Okay, so if I increase the volume, what will happen to concentration? Concentration will decrease. If concentration get decreases, so you know that concentration is directly proportional to osmotic pressure. So if concentration decreases, what about osmotic pressure? Osmotic pressure also should decrease, right? So if volume increases, what will happen to osmotic pressure? Osmotic pressure should decrease. So this is also wrong. Okay, so this is also wrong, right? Understood? So increasing the volume is also wrong. So see, again one I'll explain, don't get confused. Okay, so when we are talking about okay, so osmotic pressure is directly proportional to CRT, that is concentration into gas constant into temperature. Now when we are talking about concentration, now you know that pi, that is osmotic pressure, is directly proportional to CRT. Okay, what is concentration? Concentration is given as number of moles of solute by volume of solution. Now if volume of solution increases, if we increase, what will happen to concentration? See that concentration is inversely proportional to volume of solution. So if volume of solution increases, what will happen to concentration? Concentration will decrease. If concentration decreases, okay, what will happen to osmotic pressure? Because concentration is directly proportional to osmotic pressure, so osmotic pressure also decreases. So what they have said, if osmotic pressure increases, there will be increase in volume. No, so it is inversely proportional. So this is also wrong. Okay, so second A option is also wrong, C option is also wrong. Now we'll see B option. Okay, what is B option? So now if we increase number of moles of solute, what will happen to concentration? Concentration increases. If concentration increases, what will happen to osmotic pressure? You know that osmotic pressure is directly proportional to concentration, so osmotic pressure also increases. So the option B is the right answer. So the D option is what? Removing the semi-permeable membrane. See, if you are removing the semi-permeable membrane, there is no point of osmotic pressure. So osmotic pressure, this phenomena, it depends on the permeable membrane, that is semi-permeable membrane. So it is a flow of solute to solvent. Okay, so from low concentration to high concentration. So this is what osmotic pressure is. So removing the semi-permeable membrane, there is no meaning of osmotic pressure. So this also option is wrong. So what is our correct answer is B. Understood? Okay, understood this question? Okay, so we'll go to the next one. For carrying reverse osmosis, for desalination of water, the material which is used for making semi-permeable membrane is. So the material which is used for making the semi-permeable membrane is cellulose acetate. Okay. So this is a theory-based question. So remember, so which is the material which is used for making the this okay semi-permeable membrane in reverse osmosis is cellulose acetate. Okay. So this is the answer. So we'll go for the next one. Okay, so which of the following units is useful in relating the concentration of solution with its vapor pressure? Okay, so when you are expressing the concentration of solution in vapor pressure, so what it is, it depends on the mole fraction. Okay, A is the answer. Okay, so it is mole fraction. You're not able to chat. Yes. Okay. So vapor pressure, when you are relating the concentration of solution with its vapor pressure, the important this is mole fraction. Okay, it is mole fraction. So we'll go for the next one. An aqueous solution freezes at minus 0.186 degrees Celsius. Okay, what is its elevation in boiling point is if Kf is 1.86 and Kb is 0.512. Okay, so this is the question. So what all is given here? So we'll write what all is given. So that is freezing. This is given. So it is delta TF. Delta TF is given as 0.186. Okay, minus 0.186. Boiling point elevation is given as KF is given as 1.86. What is KB is given as 0.512. Okay, now freezing is given. We have to find delta TB. Okay, delta TB we have to find. So first freezing freezing this elevation point, we can find out the boiling. Okay, the formula we can use is delta TF is equals to KF into M. So from this we can find the M first and then we can substitute in delta TB. Now delta TF is what? 0.186 What is Kf? Kf is 1.86 into m. So m is equals to 0.186 divided by 1.86. So this will give you what? The answer comes to 0.1 m. Now from this we can use the formula for delta TB. Delta TB is equals to Kb into m. Now we know what is m. M is 0.1. What is Kb? Kb is given as 0.512. So what is the answer? The answer comes to 0.0512 degrees Celsius. So option D, right? So option D is the right answer. Okay, option D is the right answer. Option D is the right answer. Okay, so we'll go for the next one. Just see now whether you can message in the chat box. Yes. Okay. Fine. Understood the question still here? Clear? Whatever has been taught till here, it is clear? Yes. Okay. Okay, fine. So we'll go for the next one. Okay. So the next question is, okay, during depression in freezing point in a solution, the following are in equilibrium. Okay. Now, during depression in freezing point in a solution, the following are in equilibrium. A, liquid solvent, solid solvent. B, liquid solvent, solid solute. C, liquid solute, solid solute. D, liquid solute and solid solvent. Okay, so here, remember that at freezing point, the liquid and solid are in equilibrium. So when a solution, okay, when a solution of a non-volatile solute is cooled to temperature which is below than the freezing point of solution, then some of the liquid solvent will separate out as solid solvent. Okay, so our option is A, that is liquid solvent and solid solvent. So always liquid and solvent solid are in equilibrium with each other. Okay, when the solution of a non-volatile solute is cooled. So whenever you have a liquid which is of non-volatile solute is cooled, then the temperature with the temperature which is below than the freezing point of the solution, then what will happen? Some of the liquid solvent will be converted into solid solvent. So during freezing point in the solution, liquid solvent and solid solvent will be in equilibrium. That is, liquid and solid will be in equilibrium with each other. Okay, so our option is the right answer. Next question. Which of the following statements is false? A, the correct order of osmotic pressure of 0.01 molar aqueous solution of each compound is BaCl2 is greater than KCl is greater than acetic acid is greater than sucrose. Okay. Then the osmotic pressure of a solution is given by pi is equals to MRT, where M is the molarity of solution. C, Raoult's law states that the vapor pressure of a component over a solution is proportional to its mole fraction. D, two sucrose solutions of same molality prepared in different solvents will have the same freezing point depression. So out of these four statements, you need to tell which of the following is okay. So it is what? So which of the following is a wrong statement? Okay, you have to tell which of the following is a wrong statement among the following. See here, you are telling B. Okay, I'll go with the option B. Osmotic pressure is what? Pi. So pi is given as what? CRT. What is C? C is concentration. Concentration is what? Concentration is number of moles of solute divided by volume of solution. Now, what is molarity? What is molarity? Molarity is also number of moles of solute. Number of moles of solute upon volume of solution. Is it right? Right. So it is right. So this option is correct. So this statement is correct. Okay. Now, when you're talking about the osmotic pressure of these, okay, so Ba plus 2 is greater. Okay. Why? Because Ba plus 2, so when it dissociates, so Ba will be plus 1, Ba plus 2, and Cl will be 2 Cl minus. Okay. So 1 plus 2, 3. So this will be K plus. K plus ion will be 1, Cl minus will be 1. So it will be 2. So these are non-electrolyte. Okay, non-electrolyte. So this will be 1 and this will be 1. So this is also a correct statement. Now, when you're talking about Raoult's law, okay, when you're talking about Raoult's law, so the vapor pressure of a component is directly proportional to the mole fraction. So this is also a correct statement. Okay, C is also a correct statement. The false statement is D. Okay, the false statement is D. So these all are correct statements. So these are not false statement. So these all are correct statement. D is the wrong answer. Okay. Now, so two sucrose solutions will have same molarity. Okay. If prepared in different solvent, same molarity prepared in different solvent will have same freezing point depression. See, remember, so, different solvents will have different values of Kf. Okay. So, see here, different solvents will have, I'll erase this. So different solvents will have different solvents will have different solvents will have different values of Kf. Okay. Thus delta Tf will be different even if molality is same. Okay, so remember this particular statement. So different solvents with same molality. If two sucrose solutions of same molality, if it is prepared in different solvents, they will have same freezing point depression. Wrong. So different solvents, they will have different values of Kf. Okay. Although the molality, if it is same also, it will be, the value will be different. Okay. So D is the right answer. Now, when you're talking about your osmotic pressure, A option, so when BaCl2 it dissociates, okay, BaCl2 dissociates, it dissociates into what? BaCl2 dissociates into Ba plus 2 Cl minus. So what, add the stoichiometric coefficient. So 1, okay, 1 plus 2 gives you 3. So the it will be 3 here. Now KCl, when it dissociate, it will be K plus and Cl minus. Okay, it becomes 2. This is these are non-electrolytes. Okay, so these are non-electrolyte. So it will be 1. The value will be 1. Sucrose also, it will be heavy compound. So it is 1. So the correct order of osmotic pressure will be BaCl2 is greater than KCl is greater than acetic acid and sucrose. So this is also a correct statement. False statement is the D option. Okay, we'll go for the next one. So which of the following aqueous solution will exhibit highest boiling point? Now here, now all are same 0.01 molar, 0.01, this is 0.015. Now here, when you are talking about urea, so urea is a compound. Okay, it is a compound, it is a non-electrolyte. So this will be 1. Okay, it will have the value of 1. So whenever you have a so you need to remember what are electrolytes are non-electrolytes. Okay, electrolytes are those which dissociates, which can further dissociates, and non-electrolytes are one which do not dissociate. Now this, okay, sucrose also, glucose, sucrose, fructose. Okay, so these are heavy compounds which will not get dissociate. So the value will be 1 here. Here also the value will be 1. So these two compounds, okay, how they will dissociate? First I'll write for KNO3. So KNO3, when it dissociate, it will dissociate into K plus NO3 minus. So the coefficient is what? Here 1 K plus and 1 NO3 minus. So it will be 1 plus 1 is equals to 2. So this will be 2. The Vant Hoff factor here is 2. And when you are considering from Na to SO4, Na to SO4, how it dissociates? There are 2 Na plus ions. So it will be 2 Na plus ion plus SO4 minus 2. So this is what 2 plus 1 gives you 3. So which among the following will have highest boiling point? It is C. Okay. So C is the correct answer. Yes. So it is C. Okay. C is the correct answer. So now next we'll see what is Vant Hoff factor. So Vant Hoff factor, to calculate the extent of association or dissociation, Vant Hoff introduced a factor I, which is known as the Vant Hoff factor. So it is calculated as number of particles after association upon number of particles before association. Okay, I, or it is given as observed colligative property upon calculated colligative property, or it can be calculated as normal molar mass upon abnormal molar mass. So these are the different formulas to calculate the Vant Hoff factor I. So for dissociation, I will be, Vant Hoff factor will be always greater than 1. And for association, I, that is Vant Hoff factor, will be always less than 1. So relation between the Vant Hoff factor and degree of dissociation. So you need to remember this formula. So the formula used for the Vant Hoff factor and degree of dissociation is I is equals to 1 minus alpha plus n alpha, where n is the number of particles after dissociation. And relation between Vant Hoff factor and degree of association is given as I is equals to 1 minus alpha plus alpha upon n, where n is the number of particles which is undergoing the association. Okay, so these are the two different formula with considering for association and dissociation. So remember this. Okay, now, so just see the formula. So 1 minus alpha plus n alpha. So n is the number of particles after dissociation. Okay, now we'll go for the next question. So if alpha is the degree of dissociation of Na to SO4, the Vant Hoff factor I, which is used for calculating the molecular mass, is, okay. So this is the formula. So how does Na to SO4 dissociates? Na to SO4, it dissociates into 2 Na plus SO4 minus 2. Okay. So here what it will be? So the number of, this is 1 here. Okay. This is 0. This is 0. So this is given as 1 minus alpha. This is 2 are the coefficients. So it is 2 alpha. So here there is no coefficient. So it is alpha. So you know how I is given. I is what? I is, what is the formula for degree of association? I is 1 minus alpha plus 2 alpha plus alpha upon 1. Okay. So this is the formula. So after solving, what you will get, just see. So it will be 1 plus 2 alpha. It will be C. So C is the option. Okay. So C is the correct option is C. So 1 plus 2 alpha. So like this, you need to solve. Okay. So by this, we have covered the questions. Okay. So next session, we'll solve some more questions on solutions, and then we can. Okay. So if you have any doubts, you can ask, or else I'll end the session here. Okay. So in the next class, we'll be solving some more questions on solutions. Okay then. So I'll end the session. So we'll solve. We'll meet in the next class. Okay. Thank you.